Okay, so you can see here in the e-learning, I have upload about the bisections, okay, and the force positions, this morning class, and for current session, which is now, I'm going to explain about the fixed point iteration and also second method, yeah. Okay, fixed point iteration. So basically, we have done method belongs to the closed group, huh? So closed methods, we have graphical, which is last week topic, bisections, and then force position. Now we will see the methods in the open method, such that fixed point, iteration, and seconds. So Newton-Raphson will be covered on next class lah. Okay. So still the methods about the problem to solve nonlinear equations. But for this fixed point iteration and the second, I'm going to choose different function, not the FC that we have in the bisections or the graphical. Okay, so we will see different functions. Okay, so we'll start this fixed point iterations. This is example about the fx e to the power negative x minus x. Okay, please get ready with your calculator. I will ask you to compute. Okay, for fixed point iterations, there is no basic formula for fixed point. Okay, in this method, you are supposed to find the expression for x. Okay, whatever functions you have, you must express what is your x. Depends on the types of functions lah. That's why in this fixed point iteration, there is no general formula. Okay, now let's see our functions. Can you see the function fx equal to e to the power negative x minus x? You guys can see the functions here?
Yes, madam.
Okay. So in this fixed point method, you are supposed to express what is your x. So in the original equation, fx is the subject, right? So the subject always been written on the left hand side. In the fixed point iteration, you are supposed to express x, this x, make it as the subject. Okay? So when we move this x, bring it to the left hand side, so you have x equal to e to the power negative x. Correct? So once you express the x on the left hand side, then that is your gx, new function. Okay? So gx just now is originated from your x equal to e to the power negative x. Then x, label it to a new notations to gx. So the red functions here, the red color, this function is the one that we are going to use in the numerical table. Okay, this function. You might be having, let's say, different function lah, something fx equal to, let's say you have quadratic, yeah, x squared minus and so on. So you have to express x as the left hand side. So they are different way of the new transformation function, depends on the type of functions. Okay. So in the ebook, there is a example about these methods. You can see here on the fixed point iteration. Whenever you want to solve the problems in the tutorial, make sure you refer to the ebooks, some explanation and so on. Don't just depend on the lecture. Okay, so we wanted to see the simple fixed point iterations. Okay, the one that I'm explaining here is this example 6.1. That means this fixed point iteration example from chapter 6. Okay, to be detailed is in this page 143. Okay, so this is the table. Okay, so in the fixed point iterations, So that is the starting step. Always choose the correct x, but then you need to check lah that whenever you want to compute whether the computations in your table is converging or not, or diverging. So if your computation is diverging, then that means your x is not suitable, something wrong. Then you have to modify lah your functions. Okay, now let's see this dx, e to the power negative x. For this fixed point iteration, the true value is given here, 0.56714329. Okay, how do we get this one? This is the value of x when your fx equal to 0. Okay, so in order to solve, because this nonlinear function, you cannot get the answer from your scientific calculator. So you have to know how to find out if the true value is not given. Okay, this function fx, you can let it equal to 0. Okay, and then you solve for x because you have one unknown. So in order to solve this kinds of example, this function, you need to apply certain log so that you will get the true value of x as 0.56714329. Okay, so in the numerical table, we are going to consider 4 decimal places. Okay, so we start with this column I, xi, gxi. Okay, I, xi, gxi. In this fixed point iteration, the stopping criteria will be a different one. It's not based on like what we have on previous method in the bisections or the force position. Okay, fixed point iteration, stopping criteria is different methods. Okay, so I label 0 refer to your iterations. Xi is your gxi. Basically, the value is the same, except that when you want to substitute, then we get the latest value. Okay, so in this fixed point iteration, if there is no initial value or problems given, then we always assume it to be 0. Something like similar what we have on previous chapter 1 on Jacobi or Gauss ideal. What is the suitable value to start with the computation? If the value is not given, so always start with 0. If it's given, then we use the given one. Okay, so far okay or not?
Okay, madam.
Okay, now we are going to refer to the red functions color gx label. Okay, so in this in the ebook, there is no initial value, so we start with the 0 in the computations. Okay, so we start with xi, 0. Because the initial value is not given, so we put here 0, put into your rate function. X is your 0. That means e to the power 0. E to the power 0 is 1. Right. Could you please verify this with your calculator? E power 0 is 1, right?
Yes, madam.
Okay, yeah? Okay, now, so you put here gx 1. E power 0 is 1. So this one, your gx will be your next xi. Okay? Now you put here. We are at the second row, yeah? So 1 from your gx, previous gx. So 1 in your new xx, new xi, you put here e to the power negative 1. What number you have in your calculator? Round off to 4 decimal places. Round off.
0.3679.
Okay, now it's equal to the one that I show here, right?
Yes, madam.
Okay, now, so we do similarly for the next iterations. So this gx, the number here will be your next next xi. Okay, put here e to the power negative 0.3679. Okay, what numbers you have now? What numbers you have?
Zero. Similar, madam.
Okay, similar, exactly the same, for decimal places. Okay, so you do similarly for next iterations. Now, the stopping criteria. Okay, so I think you are familiar with the computations. Okay, so you do now. You can proceed until let's say here, I mark between iteration when I equal to 3 and 4, the difference. Okay, the difference here between your gx at I4 and at your I3, the difference between these two numbers is actually 0.1057. So this is the difference is still big. Okay, we stop the iterations depends on the number of decimal places or significant figure in that problem. If this is because this is 4 decimal places, right? So we stop when your difference between the current and the previous one is less than 0.0005. Okay, why that number? Because you have 4 decimal places. So you see, from I4 until your I9. Okay, and so at I9, when you find difference between your GX at your I9 and 8, still 0.0064. This one still bigger, not less than, right? So you still need another more iterations to proceed. Okay, now at your I11, 12, 13, and 14, you can see the difference. I mark here the difference. Okay, so at I14, 13 and 14, you can see the difference. Now 0.004. Previous one between I12 and I13, the difference for the GX is 0.0007. Still bigger than, right? But at the last two, between I3 and I14, the GX has different 0.0004. Then this is the first time that the difference is less than this value. So we stop the iterations. Okay, no need to proceed. Okay, if you have let's say 3 decimal places in that computation, okay, you cannot have this one. This is for 4 decimal places. Okay, if your computations work correct to 3 decimal places, then you need to check lah when it is less than 0.005. Okay, so if your computation work in 2 decimal places, so the stopping criteria must be less than 0.05, 2 decimal places. So you see that the stopping criteria is not fixed. For different methods, they have different criteria for that one. Okay, so we stop. That means using fixed point iteration, the approximation value is here. Okay, 0.5673. Any questions about this one?
No, we don't.
Okay, now it looks simple, right, to compute, right? However, the main important part for this fixed point iteration is your expression for your GX. Okay, in this case, it's very simple because you can see, the true value here is 0.56714. But when we want to use the fixed point iteration, you have this one, 0.5673. Okay, you can see it's almost similar. We didn't get exactly, but it is within the range, right? Okay, within the range. So if you find out whether the computation in these two table, in this fixed point iteration, when you compute, let's say it is diverging. Okay, diverging is very far. The value that you compute in the table, sometimes not stable, and then very far from your true value, you need to change your GX. Okay, so that is another way. That means your expression for your GX is not suitable because your computation is diverging from the true value. In this case, we got converging. Okay, because you start with 0 and then you compute everything, and then you see that all the computations are converging to your true value. Whatever you have here, it becomes closer to your true value. That is converging. But you might be having different situations. Okay, either it is not stable. Not stable means sometimes converging, but later on is diverging. Okay, so that's not stable. Or maybe You start with some number and then diverging all are very far away from your true value. That means you need to change your gx and then recheck your computation. Maybe something wrong there. Okay, so that is the remark for these fixed point iterations. Okay, now let's see the uh, relative error. Okay, relative error. uh, our approximation value using this fixed point iteration, this comes from here, the last number that you compute, which is this number 0.5673. And then we wanted to know what is the relative error, so we are using this relative error basic formula, and then you compute using the true value. Okay, substitute into this basic formula, and then we have 0.0276%. Okay, so now if we want to compare these fixed point iterations with other methods, and then we are going to take this relative error. Okay, I didn't provide the absolute error because you can proceed, but then basically if the question asks you to compute the absolute error, then you can compute lah. Otherwise, if the question did not ask, then you can just ignore this absolute error. Okay, any question? Is there anything that you want to ask here? Is there anything that you want me to repeat?
Saya, madam, apa maksud yang kena change dia punya tu kalau diverge?
Okay, let's say you dapat sama ada you salah kira ataupun you punya x ni tak sesuai. Sebab non-linear function ni dia ada banyak jenis. Bukan macam ni je. Kalau function you tukar, mungkin dia tak sesuai. Contoh, you punya function tu cubic ke kuadratik ke kan? So mungkinlah function x, gx you dalam bentuk kuasa 2, punca kuasa 2 ataupun punca kuasa 3. Dia banyak jenis. So kalau non-linear function ni bila you transform x dia jadi bentuk baru, mungkin bentuk baru function tu dia tak sesuai. So you kena tukarlah, cari expression baru. Okay, so kalau dia sepatutnya whatever you use, the numerical method that you use for solving, sepatutnya dia converge. Kalau tak converge, which is mean diverge, that means you tahulah sama ada you salah kira ataupun function you tak sesuai dekat sini.
I see.
Okay. Ada soalan tutorial I think dekat fixed point iteration, you can see dalam ebook some of the exercise function dia lain sikit lah, then you need to check. In this case maksudnya bila you nak try solve that tutorial question, tiba-tiba you dapat diverge, that means sama ada you salah kira ataupun function gx you tak sesuai. Okay, untuk fixed point iteration saja, because fixed point ni dia tak ada general formula kan.
Okay, madam.
Okay, Pragash?
So far okay, madam.
Okay ya. Make sure clear because this maths 3 dia looks macam senang nak faham, tapi ada small things that you have to be careful in this method. What is the stopping criteria? Because this stopping criteria dia tak diberi dalam assessment. Okay, you need to know lah each method what is the stopping criteria. Bisections and false positions, what are their stopping criteria? Okay, different methods, different stopping criteria.
Yeah, okay, madam.
Okay, so remark when you want to highlight. So in your notes, you have to remark here. Okay, so that is fixed point. Now we move to the second method. Second method, we use same function that we have in the fixed point. This fx e to the power negative x minus x. Now we would like to try with second method. Okay, second method, there is a general formula. So this is the one. Okay, so since same function, so we are going to use the same true value. Okay, and then in the numerical table, we still consider the same number of decimal places, which is 4 decimal places. So in the second method, since I have posted this is the general formula. Okay, now we wanted to start with the computations. In this second methods, you must have starting interval. Okay, the starting interval, the result will be the same like we have in the bisections, right? So dalam bisections kita kena pilih interval yang ada solution dalam dia. Okay, yang contain roots. Kalau you pilih interval yang tak ada roots, that means nanti computation you akan diverge. Okay, but if you choose interval yang ada root dalam dia, then computation you should be converge. Okay, so let's say something kan. If the interval does not stated, tapi dia bagi true value, then you can decide lah. Okay. Kalau true value tak tahu, then you kena solve. Find out what is the true value. If interval is given, so kita guna. Kalau interval tak bagi, then you have to decide. Okay, so usually second method, we start with the interval yang dalam bentuk integer. Okay, simple integer lah. Kalau tak ada integer, then you can start consider decimal places lah, something like this. Okay, so true value is 0.56 is 1. Okay, so if it's in the interval, so you can have something like this. Interval such as from 0 to 1. Because 0.56 lies between these two numbers kan? Right? Betul tak?
Betul, madam.
Okay, correct right? Okay, so you can choose let's say 0.2 to 0.8. No problem, okay? But usually kita start yang simple because kalau you start with the simple integer, then much be simpler for you to compute, okay? So there is no fixed value, depends. Kalau macam saya bagi tahu tadi, kalau interval diberi dalam soalan, you guna the given interval. But if it's not given, and then you kena decide. Okay, very clear. Make sure you read the questions carefully ya. Okay, so dekat sini kita ambil 01. Now, in this second method, we need to know also the estimated error because this second method stopping criteria dia akan compare dengan estimated error. So, recall back. Okay, in this function, sorry, in this example, for solving the fx, the estimated error is not given. Tak diberi. Compared to example in the bisection, the estimated error is given. There is a value. But in this example, we have different functions. So the estimated error is not given. Then you need to find out. Okay, find out. Okay, so this one, general formula, I have introduced this estimated error during our first class on the on this chapter. Right. 0.5 times that to the power 2 minus n. N is number of significant figure, not decimal places. Okay, please be careful. Now, for this example, let's say here in this table, later on you find out lah, because we have to compute for decimal places. Okay, so what we consider here in the computations here lah. Okay, so this n later on you refer back to this the numerical table. Okay, I'm going to explain again lah about this one later on after this. Okay, in the computations start with the interval. So just now we have decided to use the 0 and 1. Okay, 0 and 1 because our true value lies between 0 and 1. Okay, so according to the general formula, okay, the label here. So in this column, xi minus 1 and xi. What this means? Xi minus 1 previous value, or we call lower interval. Xi is the upper interval. Okay, so since we choose 0 and 1, so xi minus 1 is your 0, 1 is your xi. Okay, then once we identify, you have to compute f xi minus 1 and fxi. Okay, how to compute? So kita dah tahu kan xi minus 1 is 0, so you put here lah in your fx. When x is 0, what is the value? E power 0 minus 0. So you have 1. Okay? Can you write down on your paper? See this 0, put it here, e power 0 minus 0. You have 1. Okay, next. Substitute 1. So you have e power negative 1 minus 1. Okay. So the detail for the computations according to the general formula is given here. This is the label 1 minus f1 everything here. But the detail of that value is here. Okay, I'll give you, I think, 1 minute to verify the computation for the first iterations here when I 0. Okay, check Check. 0, put it here. So what is the value? 1, put it here. And then you substitute into this formula. The details you can compare these two. Okay, 2 minutes to check. You are supposed to get 0.6127. 2 minutes, 2 minutes from now. Okey ke Tengku Pragash kalau nak tanya? Kalau tak dapat boleh tanya. Okey tak? Tak ada respon je. Tak ada orang ke kat dalam line ni?
Madam, ada madam. Sekejap eh.
Okey, okey.
Madam, yang formula tu maksud dia kita kena letak, kita kena ganti X.
Ni nampak tak saya punya cursor ni? Yang saya punya cursor sekarang ni, cursor bergerak ni belum ganti lagi.
Oh, okay, okay.
Yang dah ganti kat sini. Sorry.
So yang dah ganti tu calculate je lah madam.
Calculate lah.
Okay.
Tengok betul-betul bahagian mana yang bahagi. Okay, bahagian belakang ni je yang bahagi. Sebab kadang-kadang student dia tersilap bahagi.
Oh, sekali satu. Okay.
Okay. Pragash okey ke?
Tengah digest madam. Madam, yang part bawah ni F0 minus F1 yang bawah tu kan.
Yelah F0 tadi tu dah tahu 1 kan? Masuklah sini 1.
Oh, okay. Lepas tu F1 tu yang
F1 negative 0.6321. So you masuklah, then you simplify.
Okay madam.
Okay, kalau ada F dengan number tu belum simplify lagi so you tengok betul-betul Okay, dapat tak?
Dapat.
Dapat madam, dapat.
Okay, so next iteration so kita dah dapat first row ni dapat 0.6127. Okay, so whatever yang you dapat kat sini adalah you punya new value of X. Okay, Xi plus 1 ni maksudnya latest value lah. Latest value of X. So, 0.6127 ni dia akan jadi interval Xi minus 1. Okay, dia always be. Okay, tak apa. You just compute lah. Walaupun kita tengok ni macam something wrong kan, tapi tak apa. Because second method ni dia unique sikit. You tak perlu susun interval. Kalau the computation is okay, the computation ni dia akan converge. Okay, so no issue for the interval lah. Interval maksud saya dekat sini interval dalam second method. Tadi kita start 01 kan, bukan kita start 10 kan. Okay, starting ni je you kena make sure interval tu dalam bentuk lower limit dengan upper limit. So next one lepas you kira interval tu nampak macam terbalik kan, because 1 ni nombor besar but then 0.6 ni nombor yang kecil. Okay, tak perlu susun let's say 0.6 to 1, tak perlu. That is the uniqueness of this method. Okay, so whatever you have as xi plus 1, okay, always be you punya xi minus 1. So second method ni dia unique. Okay, so still you akan dapat converge calculations lah. Okay, so at second row ni, okay, at the second row you use 1 and 0.6127 ya. So look properly xi minus 1 is 1, xi is 0.6127. Okay, so the detail of the computation is here. At the second row ni saya tak label everything F because dia panjang sangat. So saya just terus tunjuk number after computation, after the simplifications lah. Okay, so 0.6127 ni mana dapat? Once you replace 0.61 0.6127 into the formula. Okay, this one how do we get negative 0.0708? This is when you substitute your 0.6127, put here e power negative 0.6127 minus 0.6127. You get this number. Okay, and then you simplify lah and do other part for this one when you substitute 1 into this function. Okay, so your latest value is here 0.5639.
Madam, yang 0.3870 dapat mana?
Bila you ganti masuk, tengoklah label kat sini kat mana. This is difference. Cari beza this tu.
Oh, okay.
You dapatlah this one. You see general formula. Okay, so in your assessment, make sure you write down general formula, okay? Don't forget. Okay, so at the second row, we have latest value 0.5639. Now, let's see the absolute error you can compare. Just to show, not compulsory to compute, depends on the questions. This is, we have 8.65%. Okay, at row number 3, now 0.5639. Okay, 0.5639. You can, next interval you can sort lah. Larger to smaller, then you compute new value. Okay, your latest value of xi, same thing, same formula. You have 0.5672. Okay, next one. This 0.5672, you can put it here. Sorry. 0.5672. Okay, 0.5672, right? At row number 3. Okay, so that will be your interval here. Okay, compute same formula. So xi minus 1 and xi is changed to new one. Then you have this number 0.5671 and so on. Okay, now let's look at the stopping criteria. Okay, at which part we are supposed to stop? Okay. Okay, now kita tengok dekat column xi plus 1. See this column. All numbers are in 4 decimal places, right? The numbers has been computed correct to 4 decimal places. Am I right? Am I
Yes,
right?
madam.
Okay, now, how many significant figure? For this number, that one my cursor showed here, how many significant figure?
4.
4. Significant figure. The zero in front here counted significant or not?
No, madam.
No.
Okay, no. Okay, that means this number is 4 significant figure. 4 significant figure, okay? 4 significant figure. So, this n in your estimated error, this is general formula, right? This is n referred to your significant figure, not decimal places. Okay? So, n is 4 in this case. 4 significant figure, so n is 4. Okay, so you substitute, then you have 0.5 times 10 to the power 2 minus 4. Then get what is the decimal number. You have 0.005. Okay, could you please check? Dapat tak ni? 0.005 ni? Check with your calculator.
Dapat, madam.
Dapat Okay.
Dapat, madam.
Okay, so in this second method, there are two ways in the stopping criteria. The first one, kita follow bila estimated error less than bila absolute error is less than estimated error. Okay, ni macam lebih kurang bisection dan juga force position kan. Okay, ataupun when you compute absolute error, dia sama, dia tak berkurang. Okay, dia maintain, means that dia tak ada kecil lagi dah, dia still remain the same thing macam in this case lah. Okay, in this example, if we check dekat sini absolute error column, second row kita dapat 8.65%, third row we have 0.58%. Okay, then next row we have 0.02. Okay, next row we have 0.02. Okay, so in this case at row number 4 and 5, the absolute error is the same right? Is the same, including the row number 6. Okay, this is the second situation for the stopping criteria. Okay, in this case, for this example, you tak akan dapat yang absolute error less than estimated error. You akan dapat on the second conditions, because your absolute error dia macam sama exactly sama at row number 4, 5, 6. Okay, so you can stop lah. You can stop at this iteration. Okay, that means you can get around 0.56 yang second time ni because the first time ni kita tak nampak dia lagi berulang kan. Okay, the first time yang absolute error 0.02. Okay, the second one, second part yang kita dapat another second time for same absolute error is this one, 0.567, this one. Okay, so in this second method, we are going to take this value. So second method, the approximation value is 0.567.
So kita ambil the second one untuk
dekat sini.
error.
Yes.
Oh, okay.
So approximation value using second method is this one, 5670. So then you check lah the relative error 0.0253. I'll just show the percentage So you're supposed to know how to get this value. Okay, so absolute error dengan relative error, the formula will not be given in the assessment. You need to find out. Okay, so kena hafal sikit lah formula ni. Simple je kan, untuk hafal boleh kan? Okay, any question? So untuk second method, dia ada two different situation for stopping criteria. First one, kita tengok sama ada absolute error less than estimated error or not. Second one, if you face like this kinds of situation, absolute error dia sama for certain iteration, then kita tahu stop lah. Okay, salah satu for the second method. Any question that you want to ask?
Madam, formula untuk xi plus 1 ni we need to memorize madam?
Yang ni tak payah, dia akan diberi.
Oh, okay.
Dalam assessment akan diberi Okay, ni ada question. So, kita nak tengok tadi, kita tengok balik second method dengan fixed point. Function sama kan, fixed point. So, tadi fixed point, kita nak tengok method mana give us better result, better accuracy. So, fixed point tadi kita dapat relative error dia 0.0276. This percent. Now, second method dapat berapa? This percent. 0.0253. Mana lagi bagus? Method mana lagi bagus? Okay, second method here 0.0253. Fixed point ni tadi 0.0276.
Second method.
Second method.
Second method.
Relative error smaller than kan? Okay. So how do you compute? How do you conclude? How do you conclude? So this is common question lah. Common question.
So we need to say that second method is much more.
Okay, second method provide better accuracy because kena ada reason lah. Kenapa dia provide better accuracy? What is the reason?
Because it has lower percentage.
Okay, lower percentage of relative error. Jangan cakap percentage je. You have to be specific. Okay? Lower percentage of relative error. Okay, this common question lah dalam assessment. Sama ada dalam quiz, test ke, exam ke, dia akan tanyalah. Okay? Which method? Kalau ada lagi method yang lebih kecil percentage error dia daripada fixed point ataupun second method, method tu lagi better than these two method. Okay, contoh. Okay, ada soalan tak?
So far no.
Ada soalan? Tengku, ada ke nak tanya?
So far okay madam.
Okay. Okay, so saya rasa saya stop kat sini dululah ada papat nak saya ulang ke? So kalau nak refer balik general formula ni dekat slide this one dalam e-learning you tengok gambar ni saya dah upload dalam e-learning. So basic formula here, numerical terms, this is very important lah for you to remember. So ada dua lagi method, Newton-Raphson dengan modify. I think I will cover next class lah. Okay, so untuk topik quiz this Wednesday nanti saya post dekat dalam WhatsApp group the topik.
Okay madam.
Okay, anything before we end the class?
So tomorrow no class end madam.
Tomorrow tak ada because I actually saya dah bagi satu video kan.
Oh, so today class is for tomorrow class lah kan madam?
Yelah, yes.
Oh, okay.
So
madam,
hari ni saya dah cover untuk esok sebenarnya. Yes, Pragash?
This Wednesday quiz madam.
Ya, quiz tu during class time.
Okay madam.
So next week because we are in the short semester. So next week actually test 1 saya nak buat this week tapi because Fakihah ada family issues kan, ayah dia baru meninggal. So I think I will make it next week lah. Okay, test 1 nanti saya bagi topik.
Oh, lajunya test.
Okay, so kena ready every week ada assessment
Okay madam, start dia dulu.
Every week ada assessment. So kena prepare. I think Sam ni yang first time ada offer Maths 3. Jadi sebelum ni tak pernah offer short Sam
Pernah? Rasa pernah lah madam.
Tak pernah. Saya tak pernah ajar masa short Sam Maths 3. Kecuali Maths 2, Maths 4. Maths 3 ni this is first time.
So madam, kita akan ada physical class ke atau online je terus?
Next week physical class sebab all the way back 15 hari bulan.
Oh, okay.
Hopefully lah tapi saya tengok dia pun tak join kelas pula hari ni. Saya kena inform dia punya advisor. Tak tahu apalah isu dia. Sebab subjek ni offer sebab dia sebenarnya, kalau tak offer.
So, dedicated.
Yes, kalau tak memang tak offer masa short semester.
Madam, Saif yang putih-putih tinggi-tinggi tu, madam.
Ya. Nah.
Oh, okay.
Okay, so tutorial jangan lupa nak ambil quiz tu, make sure tutorial CL1 submit. Salah
Okay.
tak apa, you just submit. Kalau nak check jawapan datang office lah
Okay, madam.
Okay.
Okay, madam, noted. Thank you, madam.